Hello, in this video we are going through some basics about the active current and reactive current in microgrid mode. Here we have now grid converter with grid codes version 125. Let's first compare the parameters to the defaults. So I have changed system nominal DC, voltage reference, DC drooping, MCP control disabled, MCP close mode, DC and start, control mode microgrid, license of course. So we have zero active power. Let's see, we have this breaker here and this is our grid and the status is closed. Let's open it. Now it's open and MCP feedback is gone because I don't use the feedback. Drive should stay running. Yes. You can use the base current reference to push power or take power from the grid. Let's see what happens when we are not actually connected to anything. Base current reference 0, line frequency 50-ish, supply frequency 49.99. Okay. Here in the microgrid we can see that we have a frequency droop of 1 Hz. If we give base current reference of 50%, we can see here that our supply frequency increases half Hz, what was half of the frequency droop, because our base current reference was 50%. We also see line frequency D7 is still 50. That's because our D7 measurement is other side of the MCB. Going back to the zero base current reference, frequency goes back to 50 Hz. Then let's give minus 50. Our supply frequency goes 49.5 Hz. Back to 0. Then let's see what is our supply voltage. It's 400. And our voltage droop was 5%. That equals to 20 volts. So let's give reactive current reference of 50%. We can see that our supply voltage drops 10 volts. Back to 0, minus 50. And our supply voltage increases 10 volts. Let's try the same when we are connected to the fixed grid. We stop the unit and close the MCP and start the unit. We have still active current and reactive current about 0. Let's give 50% of reactive current reference. We don't have much reactive now. Let's go back 0. This is because we haven't yet commissioned inductor size and losses that are used in open loop control. So we activate the closed loop voltage control. Still same. And let's give the reactive of 50%. Our grid wasn't as fixed, so we end up about 30% of reactive current. And why is it? Now our grid voltage is 396, our grid voltage reference is 400. So it dropped about 4 volts, leaving us 6 volts what was voltage drop when we weren't connected to the grid. So 6 volts per 10, 60%, and because our reactive current reference was 50, we end up with the 30% reactive current. With the same logic, we should end up about 60% of reactive current when we gave 100% reactive current reference. 62.9, close enough. Here is our line voltage now 392. We have also supply voltage warning here. That's because the losses in LCL, our supply voltage is actually 323, and the protection function from here was activated. Let's go back to 0. We end up 2%. That was the offset in the previous. And then let's give -50. Now with the -50, we end up only reactive current 12%. Supply voltage is 413. Let's check what is our mindex here. It's almost 100. So in this case, we will need more DC voltage. Let's put 700 there. And let's check again. Yes, we have again about 30% there. -100. We end up 60. Our supply voltage is 478, but our mindex is nearly 100, so let's give more voltage. Let's go 790. And we end up again about 60% of reactive current. We need to have proper DC voltage that we can make necessary AC voltage and feed the reactive current. Let's go back to 0 reactive reference. And let's give now the 50% active current, base current reference. Now we can see that our line frequency stays fixed, and with the 50% reference, we end up with 50% active current. 100, back to 0, -50, and -100, and 0. Let's see what happens if the grid frequency changes. So at the moment we have a 50 Hz. Let's go here and let's put 49.5. So half of the frequency drop. And again we end up with the 50% active current. And if we now give 50% here, we end up to 100% active current. That's because our base reference is the grid nominal frequency, what has been set to 50 Hz. If we want to use frequency reference of 49.5, it's recommended to change here frequency drop offset. Let's put here monitoring value frequency reference. Now it's 50, and we gave here -0.5. We end up again to 50% because our frequency reference is 49.5 and our base current reference was 50. Let's put it 0. And then again we have a 0 active current. Back to 0. We have 50. And let's push 0.5 here. We end up again 100% with the 50.5 frequency reference. Grid frequency 49.5, and let's put back to 50. And we have now 50%. Grid frequency 50 Hz. Our reference 50.5. And back to 50 Hz. And 0 active current. Thank you for watching.